Hello, I welcome you all to this another interesting screencast, and the problem reads determine the components of the reaction HC. Determine the components of the reaction HC. Of course, for us, we are going to consider all the components C, B, C, A, all the components. We'll say all the components. We'll not just consider C, so it will be A, B, C, D, and E, of course. Alright. So we have three force members. So to start with, we are going to apply the equations of equilibrium. At the roller there, we expect AY. And then at the hinge there, we expect EY and EX. Right, so let's apply the equations of equilibrium. We'll say summation of moments about point E equal to 0 and clockwise being our reference. What do we have? We have a clockwise, which is negative AY by 6, right? 1.5 by 4 is 6. And then we have plus that force 250 newtons times 6 also, right? It's in the same line about this point times 6 equal to 0, and therefore AY is going to be equal to 250 because 6 and 6 will cancel, 250 newtons. And then we have summation of forces in the Y equal to 0 going up in our reference. What do we have? We have AY, we write down, we have AY plus EY minus 250 equal to 0, to write properly, equal to 0. And what is our AY? We've already calculated what our AY is. We just replace it there. Once we do so, then we realize that we'll have as a 0, right? 250 minus 250. So EY is just going to be equal to 0 newtons. And then finally, summation of forces in the x direction going in this direction is going to be our 0. Then we have EX equal to 0 newtons, right? So we have AY equal to 250. And then we have what do we have? AY equal to, and then EY, we're saying this is equal to 0. Okay. And EX equal to 0. Okay, so let's draw these members. We are going to dismantle this structure now. We'll dismantle it. And at this particular joint, we're going to have two reaction forces. So let's start with BD. BD, there we go. Let's say here we have the force 250. And then here, this is our B. So let's say we have BY. Then we have BX. Then at D, let's say we have, at D we have DY and DX. So let's work on this one. You can also draw in advance the rest. Let's draw the rest. So we have something like this. We have also something like this, right? Okay. I drawn them properly. Okay, let me draw them maybe up to there like that. And then the other one maybe up to there like that. I think this is good enough. I think so. So at that point, we've already found one reaction force, which is 250. And then at B, this point is A. Then at B, this is B. This B, we just expect opposite, like so, BY. And then another one like so, BX. Okay, this is BX. And at the far end there, let's assume it to be going up. This is our C, so this one is our CY, and then this one here is our CX, and then this side here we'll have our CX, and then we'll have our CY. Then at this point here, this is our D, so we'll have one going down, which is DY, and then going this side, which is DX. Then that side, we don't have any force, they are all zeros. This point is E. Okay, great. I think this is fine. Let's start with this member here, BD. Sorry. Alright, let's start with BD. Let's apply the equations of equilibrium. So let's say summation of moments about point D equal to 0, and clockwise being our reference. What do we have? These distances, we didn't take note of them. Alright, so this is 1.5, and then this one here is also 1.5. This is 1.5. So we have about D there, we have a 250 by 4.5, and then we have a minus by 3 equal to 0, and therefore our by is just going to be equal to 250 by 4.5 divided by 3. Our by is equal to 375 newtons. 250 by 4.5 divided by 3, 375. Alright, so let's find what by is. Summation of forces in the y equal to 0. What do we have? We have a minus 250. We have minus 250. Let me move this just a little bit like so. We have minus 250 plus by plus dy equal to 0. We've already found what by is, and if we replace it there, we have a minus 250 and then plus 375. We have dy equal to minus 125 newtons. Okay, so let's replace this. So this one is equal to 375. Then this one, the sign changes. It will face downwards instead. like so. So this one is equal to 125. All right. So once we found dy, then we have to find this one here, dy. The sign also here changes. Let's put the right sign. This one will be going up and is equal to 125. Okay. What else? By is just correct. Is 375. Great. So we have to find bx and dx, and we can find this by taking moments about c for a, b, c. So that we find bx. Once we find bx, then we'll find dx. So what are the dimensions for this? This is equal to, let me just use a straight line like so. Okay, so this one is 2 meters. This is 2. Let me write it properly. This is 2 meters and this is 2 meters. All right, and these are the distances here. We need them. This one from here to there. Let me also use this straight rule from there to there to there. Okay, let me wrap this. It's not looking too good. Okay, let me just draw a line like so, and then I say here, and then here, and then here. All right, something like that. So this one we are being taught is 1.5, and this is 1.5, and so are these distances the other side there. I could also do it in advance. For this one here, we have there, we have there, we have there. Okay, so this one here is 1.5 and 1.5. The other side we've already done. So let's work out on one side. So let's say summation of moments about point C equal to 0, and clockwise being our reference. We are now on member ABC. Okay, so let's work it out. What do we have? Moments about that. We have a minus 250 minus moment 250 by 3. What else? Yeah, in that direction, clockwise, and also this one. Another minus bx by bx by why am I not writing this properly? So bx by 2, all right, and then plus 375 by 1.5. Okay, so here we are dealing with member A, B, C. Here we are dealing with member BD. Let's call this one F there, so that we call this one F, so that we say FBD. Okay, so this is going to equal to 0, and therefore we have Bx equal to, let's find what Bx is equal to. So minus 250 by 3 plus 375 by 1.5, okay, and divided by 2. Okay, so we have minus which gives us a minus 93.75 newtons. Let me work it out. So we had a clockwise, we had also another clockwise, and then we had a positive one. Okay, so minus 250 by 3 and plus 375 by 1.5 divided by 2, 93.75. Great. Then we have summation of forces, okay, in the y equal to 0. What do we have? We have 250, of course, going up being our reference. We have 250 minus 375 plus cy equal to 0. Right. Therefore, our cy is just going to be equal to 250 minus 375. This gives us a 125. Okay, a 125 newtons. I see. So this is 125. Let me rub out solution there. This is 125. 125. This is 125. Okay, and then we said bx is direction changes. Instead of going out, it will be going in like this. Okay, and is equal to, let me move it a little bit behind, is equal to 93.75. 93.75. Okay. So even this one changes, direction changes. For this bx, direction will be going in like this, and this one is equal to 93.75. Great. Okay, what else? Then finally we have summation of forces in the x equal to 0, going this direction being our reference. What we have, I've already changed the direction there. We have bx, okay, plus cx equal to 0, and therefore our cx is just going to be equal to bx, which is equal to negative 93.75. Mind you, I'm using this changed one already, change direction. Okay, so cx, the direction is going to change also. This one direction will be like this, and let's write it somewhere. So this is going to be here like so. So this is going to be equal to 93.75. Okay, and this also direction changes. It will be this direction like this, and is equal to 93.75. And then finally, let's get back to this member here. We find dx. So say summation of forces in the x direction equal to 0. Going in this direction being our reference, we have a minus bx plus dx equal to 0. Therefore our dx, mind you, our bx is equal to 93.75, this one here. Okay, so getting that value there, getting that value there and feeding it here. We'll have dx equal to that's 93.75 newtons. Okay, so this one is 93.75. Okay, and so is this dx here. This dx here, we can just move it a little bit. Okay, is equal to 93.75. Alright, I think this is about it. This is really about it. Let's just now create outlines. We have by, which is equal to 375. Let's check whether it equilibrates. 250 down, 375. This, when we sum up, yes, in the horizontal it does equilibrate. What about this one? Remember A, B, C, CX, BX, 125, 375, 250, yes, it does equilibrate. 93 this side, 93 this side, 125, 125, yeah. So all the members equilibrate. We have a dy there like so. We have a dx like so. Okay. And then we have a bx like so. Okay. And then we have a cy like so. And then we have a cx like so. And so on, right? Great. So this is really about it. This is really about it. And then we have the other reactions here. We have ay. We have ay like so. Okay, and then we have ey like so. Okay, and then we have ex like so. Right, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 6, 9. Okay, there are 9. Right, I think this is about it. This is really about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.